Hi, it's retro computer time again. We're going back to the future. Ta-da! It's the Cambridge Z88 notebook computer. Z80 based, of course, as you can tell from the title. This comes from the legendary Clive Sinclair out of the UK. And he's developed several computers over the years, famously the ZX Spectrum and the ZX81. But this is the only one that came from the Cambridge company, which he set up, and this is 1987 vintage right here. It's A4 notebook size, before they even called them notebooks, and under a kilo. It's a really neat little bit of kit. I like it. Now, I thought we'd tear it down, and as a bonus, this one doesn't work. So I thought we'd have a shot at troubleshooting this thing, possibly fix it. Let's give it a go. Good on you, Clive. And here it is in all its glory. It's got one of these sort of rubber membrane type keypads. I mean, they're raised keys on there, but it feels very spongy and rubbery. I guess it was designed to be silent, you know, so you're using this thing out on the road, you're a road warrior. You know, back in the days when, well, you know, these things were used a hell of a lot by journalists and things like that, especially the Tandy 100/102, which I have torn down in a previous video, which I'll link in here if you haven't seen it. And it's a really nice bit of kit. I'm not sure what the resolution of the screen is. I haven't checked, but it's, you know, it looks like it's 80 characters by 8 lines or something maybe. It's got all the various shortcut keys. I don't know why they bothered there really, and you know, it's got some arrow keys. Pretty basic keypad though. Index, menu, help, blah. Not much else. Pretty boring. On the side here, we've got a DC input jack, contrast, nothing on the top, and on the side here, it looks like we have a serial port, RS-232 serial port, but that's pretty much all she wrote in terms of ports, although there is a connector under here. So let's have a look at that. And looks like we have a card edge connector there. I'm not sure what that's designed for, some sort of expansion header connector. One of the big selling points though of this thing were these EEPROM and memory packs. Now these EEPROM packs, they're just like Proton packs, except not as cool. Sorry. Another 80s joke there. And yes, they are actually EEPROMs. Check it out. There's the EEPROM inside there. Standard dip package in there, I'm sure, with the EEPROM window. Now that one's a 32K EEPROM, so that would be, you know, a standard 27C256 or something like that. This one is a much bigger 128K EEPROM, and you can see it in there, much bigger die in there, so you could actually UV erase these things. And these were, so this actually contains an EEPROM programmer in it, so it's got to generate the 12 volt high voltage programming pulse, presumably to program these particular EEPROMs. But you could also plug memory into these are 128K RAM pack, and you could expand this thing up to 4 meg or something like that. It was actually quite a lot of memory for its time, really. So this thing, in terms of memory expansion, was really quite a significant machine. And it comes with 32K of RAM built in, but of course you can expand that with the pack. It operating system in this thing is a custom one. It's called Oz. Beauty. And it came with you know, a word processor and stuff like that called Pipedream and Spreadsheet, I believe. So there were some built-in apps. You just power the thing on, and it ran from 4 AA batteries for about 20 hours. Brilliant. There's a nice little flip out thing here, so it tilts it while you're using it on the desk there. Really quite neat. And there's something you don't see every day. Made in Scotland by SCI UK Limited, serial number 2938. Hi to all my Scottish viewers. Sorry, I can't do a Scottish accent. And if I could, you wouldn't be able to understand me, because nobody can understand the Scottish accent, can they? And damn it, wouldn't you know it, it decided to work. This thing was not working before, and I was hoping to do a troubleshooting video. Oh, what a bummer, because I was even going to start out with the fact that when I plugged in the batteries, I could hear a very faint, high-pitched DC to DC converter noise in there. So I was going to, mention that, start troubleshooting. Oh, you've got to use all your senses, your sense of sight, your sense of smell, and your sense of hearing, as well as touch, to see if anything gets hot, things like that. So I thought I heard something in there and I was going to start with that. What a bummer. Oh, sorry, it's just going to be a teardown video, I think, unless it's intermittent. I don't know. Mate, can I, oops. Hey, I just got into basic there somehow. There you go. I just got into the Z80 Basic version 3. Copyright RT Russell. There you go. Who is RT Russell? There you go. I just Googled it and it's Richard Russell, and his company RT Russell was set up to supply the Basic to the BBC Micro back in the early 80s, and the same Basic interpreter was also included in the Amstrad NC100 and other machines. So there you go. Good on you, Rich. Now this thing I expect to find through-hole technology, of course. There might be some surface mount stuff. There'd be some surface mount stuff for like the LCD driver and stuff like that, I'm assuming, because it was definitely 87, so surface mount was around before then. But I expect to see some classic stuff. It'll smell like vintage electronics too, which will be fantastic. And got a whole bunch of Phillips screws here, and this is based on the Z80A CPU, working at a whopping 3.5 something megahertz. So absolutely screaming along for the day, but you didn't need anything faster than that, really. Have I forgotten something? No. Ta-da! Oh, hang on, it's falling apart. Looks like this top just pops off. Oh, there we go. I forgot to take the batteries out. Oops. So there you go. It's rather interesting in that that front bezel just lifts off, and there's the battery compartment. Looks like there's an inductor down there. We'll have a look at. Look at that. There's the D9 connector with a resistor soldered onto the shell as well. Look at that. I love that. Absolutely classic. And the LCD, oh, there we go. It's an Epson, made in Japan. And that one is a just like an 8-bit parallel interface or something. So that will have a whole bunch of SMD drivers in there. But that will come out later. And hey, here we go. Ta-da! There it is. Yep, a mix of basically mostly through-hole resistors, through-hole caps. Just briefly go through the main board here. We've got contrast pot over here. We've got a reset switch right up in the corner there. DC input jack. We've got a super cap there to hold the charge when you replace the batteries, because you don't want to lose everything if you got them inside your 128K RAM pack. I mean, these aren't dynamic RAMs, these are only SRAMs, so they don't need anything. They can run off the sniff of an oily rag, these things. And there's the main there's the built-in 32K SRAM chip. We've got our EEPROM there. That's the system ROM. I think it was 128K system ROM or something. It's got 2.2 written on it, version 2.2 presumably. And what's SKS? I'm not sure, but 1987 Cambridge Computer Limited. We've got another chip over here. We'll have a look at that. Here's the main Z80 CPU. That'd be the Z80A. There's the 3.8304 megahertz crystal, and a little pissant speaker there. And it looks like there's another little switch hidden inside there, so you can sort of access it through that option compartment. I wonder what that little sneaky switch there does. I don't know, but there's a whole bunch of TO92 transistors all bent over here. Lovely standard axial 5% carbon resistors. Oh man, beautiful. Oh, classic double-sided board, folks, all through-hole technology. Just love it. Looks like there's got a 32 kilohertz watch crystal there, as well as, you know, they've got some crusty old double-sided tape there sticking down that crystal. That used to be a very time-honoured method of dodgily sticking down your crystal. Just whack it on some double-sided tape. Who cares how long it lasts? And there's the Z80 CPU. It's supposed to be a Z80A, but it only says Z80 on there. Anyway, it's 8722, so this one was manufactured, well, that chip was manufactured the 22nd week of 1987. So this one is, because it's serial number 2000 and something, it is a very early unit. It's probably one of the first runs. In fact, it probably was the first production run on the thing. So looks like we've got an inductor there for some sort of little switch mode. I don't even know if it's because I don't see a controller around there. There might be, you know, a couple of switching transistors or something. I don't know, but so I'm not sure what that inductor's doing up there. Not entirely sure, but anyway, oh, hey, hang on, it just switched off. It just switched off. Oh, I'm not sure if it did that because it's going to sleep or because I touched something, or it's intermittent somehow. Well, I managed to get it going again by just hitting this button here, which looks like it's a power button because you hit it and it, you know, but why it's recessed like that? Maybe it, well, no, it looks like there's, you know, it looks like it was actually a recessed hidden switch. And by the way, this one down in here, if you hit this, it beeps, and looks like it doesn't, well, it resets the thing and refreshes the screen. So, all right, I figured it out. This is the soft reset switch down here, and this one is the hard reset by the looks of it. There you go. And because if you push this one up here, it'll actually tell you. Very quickly up there, soft reset. So there you go. And it tells you it's running Oz. I like it. Brilliant. So it seems to work just fine. So let's have a look at some other stuff we've got in here. I mean, all the TO92s, transistors there bent over, absolute classics. There are BC 558s and stuff like that, 548s. And we've got an NEC D, what is it, D65031 GF168 there. I have no idea what that one is. Obviously some sort of glue logic to replace a couple of devices that, you know, that are used in a traditional Z80 architecture machine. But yeah, look at all the, I mean, they've got one resistor network there, one single inline resistor network there, but everything else, they've got resistors everywhere and transistors everywhere. Very discreet design. And there's the super cap, of course, that's a 5.5 volt NEC 0.047 farads. There it is. And that is about all she wrote. There's not much else. There's a variable resistor there. Not sure what that one is doing, but yeah, there's a, curiously, there's this metal bar along the along these expansion plugs here, so I'm not actually sure what that's used for. You know, it's like a stiffener or something like that. You know, it's not really performing any sort of shielding function at all, really. So probably some sort of stiffening bar just for that, just for holding that connector in place. But why it doesn't go all the way, extend all the way to the end, I don't know. And there's a weird ass expansion connector for the cartridges. And you can, it looks like you can hot swap these things. It just sort of blanks the screen for a second and then pops back up, but I can't seem to access those. I've got no idea how to use these things, but there you go. Pretty old school. And I've got manual wiring, of course. You know, they've just soldered that serial cable directly into the pins on the board there. Pretty dodgy. You know, they've got there's that resistor going through to the shield on the D9 connector. Oh, dodgy as. So very dodgy 80s construction here, you know, but this is what it was like back in the 80s. This is how they'd manufacture these things. So, you know, it's they sort of really hadn't perfected the mass manufacturing techniques that they have these days with the surface mount pick and place machines, although, you know, we've got a perfectly good, you know, surface mount device there. They didn't extend that anywhere else on the board. And if we flip the board over and have a look, it's pretty conventional. Nothing going on there at all. No hacks, no mods, except for this weird looking add-on. Check this out. I don't think I've ever seen anything like that before. They've got this big copper strap going from this ground trace over here near the battery section down the bottom here, and it's just jumping that all the way over to there. They've got a plastic spacer which moves on the bottom of that, and so it basically connects this big ground trace over here all the way over to here. And why they've done that, I have no idea. It's obviously not serving any useful shielding purpose, so it seems as though they've done it for layout reasons. Like they routed the battery ground point down here, and they went, well, you know, we have to somehow get this all the way over to here, and well, we've only got a double-sided board, don't have the luxury of a multi-layer board, so we're going to have to jump the thing all the way across. And rather than putting your traditional link, which you don't see any of here on this unit, by the way, there's no wire links on this thing, they've just used a big white copper strap. I don't know, they don't need the current handling capability, so why they didn't wire in just a, you know, a black mod wire or something like that, I don't know. For some reason, they decided on that. Weird. Well, I jumped to the conclusion that that was the ground, but I measured it and it's not. It's actually the battery positive, and there it is. Of course, it's obvious. Look at the wire. The battery positive's there, and the negative of the battery is not until all the way over on this side of the board here. So it's almost as if like they maybe, you know, needed some extra current, because it does go out to one of these traces out here for this expansion header, but geez, you know, why it's that huge and wide just to jump over to here, I don't know. And how much does it draw during operation? Well, 60 odd milliamps just sitting there at the main index screen. And they have actually used two jumpers on the top here. You can see these two black wires going from the negative terminal of the battery over here. One's terminated there at that point, and the other jumps all the way over right to the other side of the battery terminal right over here. So instead of routing those, I guess they ran out of routing room, they had to jump those all the way across. Oops. Now I was actually wrong on that clock frequency. It's actually 9.8304 megahertz. So what I'm going to do is just probe the clock here and see what this thing's doing, because I suspect that it's possibly not running all the time. Because these things, like, you know, this to get it's 20 hours battery life, these things went into sleep a lot, so it might be waking up, for example, when you press a key. So it might be sitting there waiting for a key press. So let's probe the Z80 processor down here. Pin 6 is the clock line for a Z80, a 40-pin dip Z80. So 1, 2, 3, 4, 5, 6. Hello. Hello. There we go. And look at that. I'm at 2 volts per division, so it's 246. So it's running practically directly from the battery voltage. So it looks like it's not 5 volt regulating that, and that looks continuous. Hey, no, hello. There you go. Check that out. Aha. Look at that. Looks like there's a group of 2 bursts. Oops, the thing just switched off on me. The screen's gone, so let me reset that. There we go. And we're back. So there was no clock frequency when it was dead like that, so I'm not sure what's going on there. But anyway, we're 50 microseconds per division though. So 100, 200, 300, 400 microseconds it goes for in 2 bursts there. I'm not sure why it has that dead period in the middle of it, but 400 odd microseconds, and then there you go, it repeats that every 2 divisions, 10 milliseconds. So there you go. Every 10 milliseconds, there's a 400 microsecond burst of clock, and it's able to get away with that because it's obviously doing nothing. And if we actually ran a program, we would probably see that change. So I might try and run a basic program or something and see what happens. All right, I've got a very simple basic program there. It's just going to count up to a high number, print it on the screen, and keep doing that for a while. So let's run that and see what we get. All right, so that's what we're currently getting. So let me just type in run here. Oh, you can see that every time I press a key, bang, it sort of extends that pulse out there. So I'm going to press run and we should get a continuous clock. Yep, there we go. Fully continuous, and our thing's counting up. It's only it's not even to 200 yet. So it's pretty slow, this old sucker. And I've turned on the hardware frequency counter here, and it's 3.266 odd megahertz. So there you go. It's obviously dividing that crystal, that 9 megahertz crystal, by 3. But if you have a look at that, there is still a period in there where it blanks out, even though it's continuous. I'll try and single shot capture that. There we go. Bingo, we got something. And we can zoom into that here. And you notice there's a dead period there of 5, 10, 15, 20, almost like around 24 microseconds. There's a dead period. So it obviously needs to, or is stopping the clock for some particular reason for 24 microseconds in there. Not sure why. And look at this. This is what it was like in the 80s. This is how slow computers were in the 80s. Check that out. Oh, every cycle was sacred. Ooh, I feel like whistling Monty Python. So I'm sorry I wasn't able to bring you a troubleshooting video that I was hoping for. Maybe next time, but we all like a good vintage retro computer. Teardown, and this one was an absolute classic. I hope you liked it. The Cambridge Z88. Haha, Clive, what a winner. Catch you next time.